Okay, so as promised, section 3.7 is on perpendicular lines in the coordinate plane. Again, we will be focusing on slopes. Slopes are what matters. Okay, so again, let's start with a picture. Let's draw a coordinate plane. Right, here's our x, here's our y, and I will draw two lines that appear to be perpendicular. There will be one, let's call that line L1, and a second line, again appearing to be perpendicular. There we go, let's call that line 2. Alright, and I'm telling you that line 1 is perpendicular to line 2. You know that. So there's your right angle. So what is the relationship between their slopes? Well, perpendicular lines share a special relationship. Okay? And it's not easy to remember, so you know, you need to really focus on hitting it hard. Perpendicular lines have opposite reciprocal slopes. Perpendicular lines have opposite reciprocal slopes. Okay? So what in the world does that mean? Well, let's do this. Let's use this as an example. Okay? Say the slope of line 1. Okay? This is a positively sloped line. Say that slope is we'll say 3. Well then, if this is true, okay, if that's true, line 1 is perpendicular to line 2, then their slopes are opposite reciprocals, so we should know that the slope, of line 2 is the opposite reciprocal of 3. So what we need to do is we need to take 3 and flip it upside down. Well, 3 is 3 over 1. So we flip it upside down, 1/3. There's the reciprocal part. But then the opposite part comes from the sign, right? You take the opposite sign. If the slope of line 1 is positive, the slope of line 2 is negative, -3. And there's your opposite reciprocal slopes, 3 and 1/3. So 3 and -1/3 are opposite reciprocals. Okay? So there's an example for you to use, okay, as opposite reciprocals. So we need to remember this idea as we go forward through this video. Okay, so I'm going to put an example up here that's a drawing, and then, you know, pause it, and you can copy that. All right, so here's my drawing, okay, and you have two lines, BD and AC. So the question is really, are the lines perpendicular? Is AC, line AC, perpendicular to line BD? That's the question. Okay? And we'll use slopes to figure this out. So let's find the slope of line AC. Okay, and let me do it in the color. So AC is orange. So the slope of AC equals, again, we're going to use that slope formula, y2 minus y1 over x2 minus x1. You can also count if there's a grid. Remember I talked about rise over run, but here we don't have a grid, so I'm not going to count. Okay, I'm not going to count. Sorry, that's a -1. Okay, so if we do, say this is my x2, y2, and this is my x1, y1. Okay, so we'll do 3 minus -1, sorry. So that's this 3 minus this -1 over -1 minus 1. Okay, change your double signs. We get 4 on the top, we get -2 on the bottom, and the slope would be -2, right, if you divide. So there's the slope of line AC. So let's check the slope of line BD. So the slope of line BD, here we go. So let's use this as our x1, y1. This is my x2, y2. So we have 0 minus 2 over -2 minus 2. That's going to be 0 minus 2 is -2. -2 minus 2 is -4. And if we simplify this, this comes out to be +1/2. So the question is, are these two slopes opposite reciprocals? And the answer is yes. They are opposite reciprocals, so line AC is perpendicular to BD. And again, it's because these two slopes are opposite reciprocals. Okay, so there we go. Alright, and now let's do one more example together. Okay, so here's the last example I have for you folks. Okay, so given the line, and we'll use the same line as before, 3x plus 2y equals 6. Find the line, perpendicular this time, perpendicular through 4, -1. Okay, so this time we're talking about perpendicular, but it's the same information, so not a big deal. So again, remember, we need a point and the slope. We need the slope first of all to talk about perpendicular. So we need to take this line and find the slope. We don't know what the slope is. And in order to find the slope, we need to put it in slope-intercept form. Okay, so what does that mean? Well, we subtract 3x from both sides. 2y equals -3x plus 6, and we divide by 2. Everything gets divided by 2, just as before, and we get y equals -3/2 x plus 3. Okay, just as before. So the slope of this line is -3/2. But here's where our line comes into play. Our line is perpendicular, so we are not going to use this slope. Okay, this is not the slope we use. We need the opposite reciprocal slope. So if we take the reciprocal, we would get 2/3, and the opposite of negative is positive. This is the slope we want with this line, our x1, y1. Okay, that's what we want. Slope of 2/3, x1, y1. So now we use the point slope form, y minus y1 equals m times x minus x1. We plug in our y1, which was I'm sorry, I had the wrong point up here. Okay, let's change this all together. This is the point for -4, 1. That was the point earlier. So sorry about that. This is the point -4, 1. Okay, so make sure you made that change. So now we do y minus 1 equals the m, which is now 2/3. We're not using this slope. We're using, I won't erase it that bad. We're using this slope, 2/3, the perpendicular slope, x minus -4. So y minus 1 stays the same over here. We get, first of all, change your double signs, and we need to distribute the 2/3, so we get 2/3 x plus this 4 goes to the top. We get 8/3. Do not use a decimal. Use that fraction right there. Then we need to add 1 to both sides. Okay, so maybe we need to do this. We need to do this on the side somewhere, right? Positive 8/3 plus 1. Well, I can make 1 become 1 over 1, and I need a common denominator. The common denominator would be 3. So multiply your top and bottom of this fraction by 3. We get 8/3 plus 3/3, which would be 11/3. And there's our answer. Y equals 2/3 x, and this comes out to be plus 11/3. And there's your one perpendicular line through the point to that line. Okay, and that's these two sections. So bring this to class, and you will be working on some problems. All right, thanks for watching. Bye.